We have some interesting notation in this problem. The function f is given right here. This notation here means that the function that we're investigating is the inverse of that function f. This notation means that we're going to take the derivative of the inverse of that function f, and this means we're going to evaluate that derivative at an x value of 17. To give you a clear idea of what's going on in this problem, let's look at a general picture of a function and its inverse. So let's say our function looks something like this. What we know is we get an inverse of a function by reflecting the function over the line y equals x. So we'll call this function f here. I'm not saying that this is exactly what this given function looks like. This is just an example. But if we reflect this green curve over this 45-degree line here, what we get is something that looks like this. All right, that looks close enough. That is going to be our f inverse. Now let's take a look at a specific point on the graph of f. Let's call this specific point x0, y0. Well, something that we learned about inverse relations is you always get an inverse by switching all of the x and y values. So if this point here is x0, y0, then there's a corresponding point up here that has the x and y values switched. Okay, now that we have that basic graph, let's investigate the relationship between the derivatives at these 2 points on these two different functions. More specifically, let's try to figure out what the relationship is between the slope of this tangent line and the slope of this tangent line. Well, we've always learned that the slope of a line is rise over run, or the change in y values over the change in x values. Well, since we know that with an inverse function, we're changing all of the x values and the y values, the rise for this function is the same as the run for this function, and the run for this function is the same as the rise for this function. That's maybe a long-winded way to say that if the slope of this tangent line is m, then the slope of this tangent line is 1 over m. They're reciprocals of each other. Well, if you're with me so far, then that's great. The last hurdle that we need to get over is notation for this concept. So let's try to figure that out. Let's start by focusing on the inverse function, f inverse. What we're going to say is that the slope of a tangent line on this f inverse function, evaluated at an x value that we're calling y naught, is going to be the same thing as 1 over the slope of this tangent line here. Now, how do we write the slope of this tangent line here? Well, that is simply the function f prime evaluated at the x value x naught. Let me shrink this whole thing down a little bit so we have a little bit of room to do this problem now. We want to find f inverse prime of 17. Well, that tells us that our y naught in this formula is equal to 17. Well, if we're going to use this formula, we need to figure out what x naught is first. Well, they gave us a function up here. We can plug y equals 17 into that function and see if we can solve that for x. Now, there's a couple of ways that we could do this. I'm going to subtract 7 from both sides. I don't want to use any kind of cubic formula, so I'm hoping that our x value is going to be easy to find. You could use a graphing calculator to do this, but let's just guess a couple of simple x values. I notice that if I plug x equals 1 into this right-hand side, I get 1 plus 1, that equals 2. I notice that if I plug x equals 2 into this right-hand side, I get 2 cubed, which is 8, plus 2, and that does actually equal 10. So maybe we got lucky, maybe this problem is designed to work relatively well for you, but I'm noticing that x equals 2 is a solution to this equation. That is the x value that corresponds with y equals 17, so we are going to call that x naught, or x sub 0. Okay, now that we found that our x naught value equals 2 for this problem, we just need to plug that in right here, and we get 1 over f prime of 2. So again, I'm going to zoom out just a little bit here to make a little bit more room. Our goal now is to find f prime of 2. Well, f of x was given, so we can find its derivative. The derivative of x cubed plus x plus 7 just uses the power rule. It's 3x squared plus 1. Now, f prime of 2 is what we get when we substitute x equals 2 into that. And I'm getting 12 plus 1. I'm getting an answer of 13. We can plug that result in right up here, and we get a final answer of 1/13 as f inverse prime of 17. Okay, I think that these problems have pretty confusing looking notation, so I hope that that video helps you out, and I hope to see you in the next one.